Hey classes, welcome back. There's so much to talk about this week. I'm not quite sure where to begin, so let's just kind of jump into today's notes and I'll kind of backfill some of the other stuff that we did. Let's check out what we had for today's Brain Pop and our introduction. Today we're talking a little bit about primary consumers and decomposers. Over the beginning of the week, we talked a little bit about the food web or food chains and how everything is really dependent upon the sun. But one thing I was really glad that they put into today's Brain Pop was over the last 2 or 3 years, we've been talking a little bit about how up on the North Coast, they found a whole ecosystem that was based upon not the sun, but chemical energy that came from within the earth. In other words, geothermal energy that was putting out these hot water spots that certain bacteria could make use of those chemicals and then feed tube worms, which then fed an entire little ecosystem. Right off here on the coast of California is one of the first places they saw it. So that's one of the things I just want to point out I love about science is that it's constantly being updated, it's constantly being added to. It's one of the most dynamic subjects that we have here at school. For us, we were concerned with primary consumers today, the things that are eating the producers. And of course, we talked a little bit about how we're secondary consumers or secondary carnivores and decomposers, which on the video today, again, the little video clip on Brain Pop, they pointed out something that I really am glad they did because I always try and make sure that we spend a lot of time with the decomposers. You may remember if you were in 5th or 6th grade, they talked about the FBI if you were at outdoor ed, fungus, bacteria, and invertebrates, the big three if you're talking about doing composting. The decomposers are critically important to any healthy ecosystem. We're going to spend a lot of time on them. And I wanted to spend a little bit of time today showing the class some of the worms and some of the bacteria that were used in the biggest little farm, a great little story that shows a little bit about how the food webs fit together, taken right here in California, and also the challenges of farming in California. Everything from aquifers that are being depleted to the droughts that are happening more often. If you check out where we went from there, excuse me, the energy pyramid. Not drawn to scale. What I mean by not drawn to scale is if I were really to show that it's only about 10% of the energy going from level to level. What we really mean is most of the energy gets lost. I wanted to challenge students to think about, hey, where are we losing this energy? Most of it gets lost to heat. When you're talking about, for example, going outside the classroom right here, the students were running in their PE classes a mile a little while ago. You obviously feel hot after you run for a little while out there. And that was one of the things that lose the energy as we go from level to level. Remember the producers, the plants, the photosynthesizers are busy putting sugars together using energy from the sun, rearranging carbon dioxide and water, and they're putting together these big long sugars. And when they do that, they mean to use that sugar for growth and reproduction. However, if you look at the herbivores and then on up the food pyramid, the primary carnivores and the secondary carnivores, we say, hey, producers, thank you very much for going to all the trouble of putting all that together. Now we're going to take you and eat you. We're going to take that energy. John Muir, in one of his books, My First Summer in the Sierra, put it really, really well when he was talking about sitting around a campfire here in the Sierra. It was one of his first times up into the high country, and he was sitting around a giant campfire, and he was saying how they were enjoying the heat from past summers. It was a great, very, very poetic way of putting it. I encourage you to read some John Muir. We'll have some John Muir excerpts throughout this year. And in John Muir's book, he was talking about really feeling the chemical energy that the plants collected from the sun summers before. Moving on to one of the next things that we saw, and I'm at the limit of my microphone here, so bear with me. If you look at what kind of energy, when we're talking about energy going up the food pyramid, what kind of energy really are we talking about? We're talking about chemical energy, the energy that something has by virtue of having chemical bonds. Here's a goofy tie-in. Again, always looking for the stories to kind of bring things together, and we remember things better when they go with the story. I had a picture up on the board. Right now it's just a whiteboard picture, but we had a picture on the board of the Shoreline Amphitheater. Now, I'm not sure if you're familiar with the Shoreline Amphitheater. It's a local venue where a lot of people play concerts. I saw Eric Clapton there many, many years ago, things like that. My daughter, I know, saw a concert there not that long ago. I'm at an age now where I pick people up from concerts instead of go to the concerts. I mention it because of this. At the Shoreline Amphitheater, amphitheater, they have a seating section with the paid seats where you sit down and have a comfortable chair to sit in. Or you can hang out, let me pull this one over again. You can hang out on this area right here while you're watching the stage, and this area right here is the grass area. Goofy thing happened when they first started to do this. The Shoreline Amphitheater is built on a former landfill. Matter of fact, I remember when I was a kid growing up around here, taking things like lawn clippings and such down there with my dad in his old pickup truck, and we would use this landfill like everybody did on the San Francisco Peninsula. I grew up in Millbrae. That being said, you've got this landfill upon which it was built. When the garbage dump was filled up, they put some dirt over it, and they said, okay, what do we do with this land now? Part of the land went to business parks. Part of it went to the Shoreline Amphitheater, where you can see concerts to this day. And as would happen sometimes when people put out their blankets and they're sitting there watching a concert, people would be smoking cigarettes. Now, not a big fan of smoking cigarettes. But as you probably know, cigarettes being very, very hot, when you go to crush them out, people would hang back on the blankets. You can read this for yourself online. I'll link to it down below. And they would crush out a cigarette, and all of a sudden, every once in a while, you'd see this blue flame shoot up. It was methane gas. What was going on, and they didn't see this coming at the time, was the following. The decomposers in the environment, the stuff that we had dumped there years before, was now being worked on by the bacteria. That bacteria was making a gas called methane. And methane, as you may or may not know, is volatile. It burns very easily. With the gas coming up, being sparked from old cigarettes that were being crushed out, they had to actually go back in here and put a bunch of pipes underground to try and make sure that none of the gas would come up and cause that kind of problem again, because it's not really a good business model to have your concert goers bursting into flames while they're watching their favorite band. So if you go down there to this day, you see these big garbage can looking things kind of dotted around the area with little flames at the top that go on once in a while. The pipes carry the methane gas over these garbage cans, and they're not really garbage cans, they're holding tanks. And then it gets burned off in a more safe manner. The point being, the decomposers are putting that methane gas into the environment. Incidentally, when we talk a little bit more throughout the course of the year about global warming gases, landfills account for about 25% of the global warming gases that we're putting up in the atmosphere. And methane, CH4, again, we talked a little bit about methane today. Methane is a much more powerful greenhouse gas than even carbon dioxide. It holds in the heat in our atmosphere much more efficiently than carbon dioxide does. So we have to talk a bit about this. Also, we'll talk about methane over the course of the year as we talk about how we burn fossil fuels. Okay, when we're talking about how the energy is stored from the sun, again, really the focus of the day today was trying to make sure that students had an idea that the energy is held in chemical bonds. We drew CH4, good old methane, a non-polar, kind of balanced out molecule on the board, an organic molecule. And when you break one of these bonds, the bonds are represented by the little sticks in between the atoms. Black, of course, being carbon, blue this year being hydrogen. When you break those bonds, you're releasing energy. Interestingly enough, CH4 combines with O2 in the atmosphere to make carbon dioxide, another global warming gas, and H2O, water vapor. Moving on from here, we had a little bit of a cut and paste. It looked, before it was actually colored in, it looks like this right here. The idea, of course, is to show how energy moves throughout the food web. And again, it gets back to the first screen over there about how the producers make up the bulk of any healthy ecosystem, and then it works its way up. Finally, the biggest little farm, a little tiny clip from that was meant to show today the relationship between the decomposers and a healthy soil, healthy ecosystem. A couple other things that we talked about this week. The water molecule, which I believe is behind me. I think you can see it over here. We've drawn the water molecule a couple of times this year. This time we made sure to add the little plus and the minus to it. Water molecules are what we call polar. Just like our Earth is polar, a compass aligns itself north-south. A water molecule is polar as well. That little plus side and the minus side is critically important to life. When you're talking about water being the most important compound for life, one of the many reasons why it's so important is because it's a little bit lopsided. It looks like the Mickey Mouse with the ears at the top, if you will. And if you've got that plus side and the minus side, one of the characteristics that this helps out with is when it freezes, When it gets cold, the pluses and the minuses all line up in a crystal lattice. It makes ice expand a little bit. Water is one of the only substances that expand as it gets colder, and that makes ice float. If it wasn't for that fact, think about it. If ice sank, our planet would be mostly frozen, perhaps a little bit of liquid water right at the top where the sun was thawing it out. Critically important for life, but the other reason, the more important reason, is that water is called the universal solvent. Again, that was from the notes a couple of days ago. It does a fantastic job of taking things all over the planet. And remember, our oceans are downhill from everywhere. And so many of the things that we have up here on land and our aquifers, and again, the aquifers are out there on our notes, carry things right out to the oceans. A quick example of something that's on the bigger side that you can actually see it to make it a little bit more real was this. I was talking about these in class, which are the beads that they hand out. Now, I'm a big fan of having the spirit days with 6th, 7th, and 8th grade, but the beads are made of plastic. See, these tiny little beads right here are made of plastic, and about 100 meters that way, the way I'm pointing right now, is the ocean, the biggest physical feature on our planet on the surface. And see these beads in here, what it collected in, just about an hour outside during yard duty today. The point being, those little beads, microplastics, get carried out to the ocean out here. And when you're talking about microplastics being collected in our oceans, you're talking about a great example of how water brings everything all over the planet. Now, this is a big example when you're talking about tiny chemicals, when you're talking about things like radioactive waste, when you're talking about any kind of pollution. And again, pollution is a major focus of 7th grade biology. Water, because of its polarity, because it's liquid across a wide range of temperatures, does a fantastic job of distributing things over our entire planet very, very quickly. So that's going to be an ongoing theme throughout the year. Quick recap of what we did today and where we're going. Don't forget that we've got our online test. It's online all the way through tomorrow. And our key terms, our 12 key terms this week, was our spot check. Have yourself a wonderful, wonderful Thursday, everyone, and I'll see you online. Take care. Bye-bye.